Hello everyone, myself Hans. Today we are going to solve the problem of UPSC 2014 problem from topic ordinary differential equation. UPSC asked in 2014 for 20 marks. Let's solve the problem. Given differential equation is, this is given by x cube d3y upon dx3 plus 3x square d2y upon dx2 plus of x dy upon dx plus of 8y is equal to 65 cos log x. How to approach this type of question? This is the Cauchy homogeneous linear differential equation. Given differential equation is Cauchy homogeneous linear differential equation. So we have to putting x is equal to e to the power of z and taking log both the sides. This gives log x is equal to log e to the power of z, and with the property of log we can also write this is z log e, and the value of log is 1, so we have to write here this is z is equal to log of x, and we can also know that x3 d3y upon dx3 is written as d minus 1 and d minus 2 into y, and we can also know that this is x square d2y upon dx2 is written as d minus 1 into y, and x dy upon dx is written as, this is written as dy, and we have to put in the given differential equation. Then differential equation becomes, here we have to put x3 into d3y upon dx3 in place of, we have to put this is d minus of 1 and d minus of 2 into y, and here we have to put in place of x square d2y upon dx2 and plus of 3 is already present, and we have to put in place of x square d2y upon dx2. This is written as d into d minus of 1 into y, and for x dy by dx we have to write here plus of dy, and here plus of 8y is already present, and we can also write 65 cos, we have to here let x is equal to e to the power of z, and taking log both the sides we get z is equal to log x. So we have to put in place of log x this is z. The differential equation becomes, and further we have to simplify, this is written as d, and we have to multiplying d minus 1 and d minus 2, this gives multiplying with d square minus of 2d and minus of d and plus of 2 into y. Again we have to check, d multiplied with d minus 2, this gives d square minus of 2d, and minus of 1 multiplied with d minus 2, this gives minus of d and plus of 2, and further we can also multiply here, this is given by 3d multiplied with d, this gives, once again we have to multiply, this is written as 3d square y, 3d square y, and minus of 3dy, and here is dy is already present, and plus of 8y is equal to 65 cos z, and further we can also multiply here d with this bracket, this gives d cube minus of 2d square minus of d square and plus of 2d, and here we have 2 multiplied here. This is y, and plus of once again 3d square y, and minus of 3 dy and plus of dy. This gives minus of 2 dy plus of 8y is equal to 65 cos z. And we have to take y common from left hand side. This gives d cube minus of 2d square. Here minus of 2d square and minus of d square. We can write minus of 3d square plus of 2d, and here plus of 3d square, and here minus of 2d, and here plus of 8. And we have to take y is common from left hand side. This gives 65 cos z. And from here 3d square to plus 3d square to minus 3d square is cancelled out, and plus 2d and minus 2d is also cancelled out, and the remaining is here. This is d cube plus of 8 into y is equal to 65 cos z. This is a linear differential equation, and we have to find the auxiliary equation. First, to find the complementary function, here we have to find, this is find auxiliary equation. We can write here, this is m square plus of 8 is equal to 0, and from here this is, we can also write, this is m cube. This is m cube. M cube plus of 2 cube. On 2 cube we get 8 is equal to 0, and we have to use the formula. This is written as, once again we have to write here, this is a cube plus of b cube is given by a plus of b, and in the second bracket this is a square minus of ab plus of b square. So we have to use here, this is written as m plus of 2, and in the second bracket we get m square, and here minus of ab, this is given by minus of 2m, and once again minus of 2m, here not here, minus of 2ab. So we have to write here 2ab, this gives minus of 4m. A cube plus b cube is written as a plus of b, and in the second bracket this is a square plus of b square minus of 2ab. So we have to get here m plus of 2 and m square minus of 4m, and the b square is written as 4, and where this is equal to 0. Simply from here this is m plus of 2 is equal to 0, and m square minus of 4m plus of 4 is equal to 0. From here m is equal to minus 2. We get the first root, and solving this we use the Sidraccia formula. This is given by m is equal to minus of b plus minus of under root of b square minus 4ac upon 2a. We have to use this formula. Once again, here some mistake is happened. Here is only AB. Sorry, we have to confuse here. Once again, this is minus of AB, so we have to write here minus of 2m, and minus of 2m. This is given by also, this is 2, and we have to use this formula. We get the second root, and from here on applying, this is m is equal to here minus of b. B is here minus of 2, and minus is already present, so we have to write plus of 2 plus of minus under root b square. Minus of 2 square is 4 square, and minus of 4ac. 4 into a, coefficient of a is here 1, and c is given by 4 upon 2a. this is given by 2. We have to solve here. This is given by 2 plus minus of under root. Here 4 minus of 16. 4 minus of 16 upon 2. And we can also solve, this is written as 2 plus minus of under root of 16 minus of 4. This is given by minus of 12 upon 2. And we know that in complex solidity, this is given by I square is given by minus of 1. So we have to put in place of minus, we have to put I square. So we have to get here m is equal to 2 plus minus under root of, we have to write 12 is written as 4 into 3, and we have to write in place of minus, we have to write I square, and here is 2, and we have to take 4 from root. This is given, 2 is taking common, and this is written as once again, this is 2 plus minus of, here from root we have to take 2 common. This is 2 to the 4. This is 2i is taking common. Here is I square, on taking into square root, this gives 2i, and under root of 3 upon 2, and taking numerator from 2 common, this is given by 2 is taking common, 1 plus minus of under root 3i upon 2, and 2 to 2 is cancel out. Here the complex roots of the m is 1 plus minus of under root 3i. So we have to write complementary function first. Once again, we have to write in complementary function. We have to write complementary function. Complementary function is written as, here the real roots is m is equal to minus of 2. So we have to write c e to the power of minus 2z, and plus of, we have to find, write for complementary function for complex roots. So we have to write e to the power of z, c2 cos root 3i, and once again cos 3 root, so we have to write here z, and plus of c2 sin root 3z. This is the complementary function. Further we have to find a particular integral. Once again we have to find particular integral, and we can also put here the value of z. This is, here we have to take x is equal to e to the power z. So we have to write here, this is x square is equal to e to the power 2z, and in place of e to the power 2z we have to write x square. This is given by complementary function is written as c1 e to the power of minus of x square plus of e to the power of x into c2. Once again we have to write c2 cos root 3. In place of z we have to put log x. This is written as log x plus of c2 sin root 3, and again we have to put in place of z, this is log x. This is the complementary function. And further we have to find particular integral. Particular integral is given by, once again we have to solving for particular integral, and particular integral is given by 1 upon of d cube plus of 8 into 65 cos z, and we know that d is in Cauchy differential equation, d square is equal to minus of 1, second order derivative is equal to minus of 1. So we have to write here, this is 1 upon d into d square plus of 8 into 65 into cos z, and we have to put in place of d square, we have to write here minus 1. So we have to write in here 1 upon of minus of 1, we have to write, this is given by minus of d plus of 8 into 65 into cos z, and further we have to solve we can also take minus common. We have to write particular integral. This is minus of 65 is taking common, and this is written as 1 upon 8 minus of d into cos z. Here 8 minus of d, on multiplication of minus, this gives minus of 8 and plus of d. So we get here, once again we have to write here, this is written as once again d minus of 8, sorry, on multiplication with minus, this gives minus of d and plus of 8. We get the above result. And further from here we can, here we have to rationalize d, 1 upon d minus of 8 is rationalized. This is given by minus of 65 into 1 upon of d minus of 8 is rationalizing. This is given by d plus of 8 into d minus of 8. Once again we have to write some mistake, minus of d and plus of 8. This is right is, and into cos of z. And further we have to write, this is written as, once again we can also write, this is, once again we have to write some mistake. This is minus of d and plus of 8. We have to write minus is taking common here, and we have to write d minus of 8. D minus of 8. We have to rationalizing here, this here is also plus. D plus of 8 and d plus of 8. So we have to solving for particular integral. This is given by minus of 65 into d plus of 8 into cos of z upon here a minus of b and a plus of b. We have to use this formula. This is written as a square minus b square is written as a minus of b and a plus of b. Similarly here d minus of 8 and d plus of 8. So we have to write here d square minus of 64, and we know that again in the second order differential equation d square is equal to minus of 1. So we have to write here minus of 65 into d plus of 8 into cos z, and we have to put here in place of d square we have to write minus of 1. This is minus of 1 and minus of 64 is already present, and further we have to solve. This is given by minus of 65 into d plus of 8 into cos z upon here minus of 65, and from here minus of 65 to minus of 65 is cancelled out, and we have to solving further. This is written as particular integral is equal to here d plus of 8 into cos z. We have to write d cos z plus of 8 cos z, and we have to here differentiating cos z. This is written as minus of sin z and plus of 8 cos z, and the particular integral is given by, this is 8 cos z minus of sin z, and we have to write the final solution. Once again we have to write complete solution. Complete solution is written as complementary function plus of particular integral, and here complete solution is given by, first we have to write a particular complementary function here. This is given by c1 e to the power of minus x square and plus of e to the power x into c2 into cos root 3 log x and plus of c2 sin root 3 into log x plus of, here we have to add particular integrals. This is given by 8 cos z minus of sin z. This is the final solution of the given differential equation. UPSC asks in 2014 for 20 marks. Thank you class, and thank you for watching. If any doubt, kindly request everyone to comment in comment section.